Okay, so let's take a look at our different states of matter. So our different physical states of matter here. So we had talked about this a long time ago, I think in topic 1, about how molecules have different states and they go through these phase changes. And these phase changes are different processes that change these substances from gases to liquids to solids and vice versa. And we can label these. So freezing is where we're going from a liquid to a solid, where say like your liquid water turns into ice cubes. Our melting is the opposite, where your ice cubes melt and turn into liquid water. We have condensation, which is where gas goes from a liquid. This is best represented when you have like a cold glass of ice water on a hot day and you see some water accumulating on the outside of the glass. That's actually water from the air outside hitting the cold surface, cooling down, and condensing on the outside of the glass. So that's not water like spilling over your cup, that's water from the air coming and reforming liquid around the outside of your glass. The next one is vaporization, or you might hear it called boiling. Technically not quite the exact same thing, but we're going to call it boiling. So we're going from liquid to gas. So this is represented by when you boil water, the bubbles come up and steam is let off. Steam is water in its gaseous form. So we're seeing it go from liquid to gas. Then we have the sublimation process, which does not happen with water as is. You can manipulate it to get it to do it as such, but we don't do that. So we don't see sublimation very readily. It's when you go from a solid straight to a gas. There's no liquid phase. And then the opposite is deposition, where you go straight from a gas to a solid. There's no liquid phase. Okay. These are our different physical changes that a substance can undergo. Now, something that's really important to understand that I want to add on to your learning from topic 1 is that in order to go from one state to another, from a solid to a liquid, liquid to a gas, these molecules, they're together, they need to move further apart to do that. Remember, these molecules are charged. We have intermolecular forces that pull them together, that hold them together. So when you're going from here to here, that's a really big deal because you have to break those intermolecular forces or move them temporarily. And so this requires energy to be able to do this, to get them further apart, because there are things that hold these things together and you've got to break them in order to do that. So that's easily thought of when we think about water boiling. So in order to go from a liquid to a gas, right, normally we have to put water on the stove top and heat it up. So we have to put heat in, which is heat energy, in order to get it to go from liquid to gas, which is expanding your molecules from here to say here. This is also seen in a phase change diagram. So phase change is when you go from one physical state to another. So when you go from solid to liquid, liquid to gas, vice versa. This requires a lot of energy in order to break these bonds and move them apart. So you can stay a solid for a long time. You can heat a solid for a long time. You can heat it and heat it and heat it. You can add in this heat. You see this temperature over here. We're adding heat, we're adding heat, we're adding heat. But it doesn't undergo a phase change until it reaches like a critical temperature, until it has enough energy. Then it'll finally transfer into a liquid. And you see this time here? Look at this time it takes to do that. So what's happening here is the temperature goes up and up and starts absorbing that energy and absorbing it and absorbing it. And it takes a certain amount of time to absorb it, and it finally has enough energy that it can break these molecules apart and turn into a new phase, which is a liquid. The same thing happens when it goes from liquid to gas. We add heat, add heat, add heat, add heat, and then it starts absorbing all of that heat. And once it finally absorbs enough heat, it can break those bonds and move further apart. So that's a critical thing to understand. So whenever we try to pull molecules apart, what's happening here? We're seeing that energy has to go into the system. We have to put energy in order to break these bonds apart. Now, let's take a look at what happens when we try to bring molecules together. So say we're going from gas to liquid, right? Or liquid to solid. we're bringing them closer together. So that's really easy to do. The molecules are like, oh, okay, cool, great. That's a lot easier to do because we already have attractive forces between them in the form of intermolecular forces. So what happens is that's favorable. And so there's actually energy being released. When it goes from here to here, it's like, oh, good. I don't need that energy anymore. I'll let it out into the environment. I had to have that much heat in order to be expanded here and to resist intermolecular forces. Now that I'm not resisting them as much, we're closer together, all that energy can go back out into the world, out into the environment. I don't need it. And so we're seeing this energy is really critical to what phase these different molecules are in. Okay, so I'm going to ask you to apply this knowledge. When a substance boils like this, does energy go in or out of the substance based on what we learned? And when a substance freezes, does energy go in or out of the substance? So we're seeing heat, energy in, so heat out or heat in when this process occurs. Are we seeing heat out or heat in? Which one of these is happening in order for this change to occur based on what we just learned? So in order for a substance to boil, when it goes from liquid to a gas, we're going to have to put our heat in. It's literally right here, heat in. We have to put heat in order to get it to do that. So the opposite is true for freezing. We're going from here to here, so it releases that heat. Heat out. So it's a little bit not intuitive to think of ice as giving off heat, but that is what's happening. If you think about how a refrigerator works, it kind of makes sense. So think about if you put something hot in your refrigerator, what it has to do is it has to take all that heat and it's got to pull it out of the refrigerator so that it can cool it down, right? So it's literally taking the heat off of your food, removing it out the back end of the refrigerator so that it can cool it down or freeze it if it's in the freezer. So this is a really important concept to understand for when we go into topic 10.3, where we're going to talk about boiling points and melting points and how intermolecular forces between molecules affect these phase changes like boiling.